So first things first. What we did yesterday was we talked about finding the limit at a point graphically, looking at graphs. Okay. Today, what you are going to be working on is finding these limits algebraic, which oftentimes is much easier than graphing because you don't have to graph anything and you can just use algebra, which actually turns out to be much easier than what you might anticipate. Alright, so the first thing that we're going to do is we're going to look at what's called the substitution method. This is an amazingly easy method. Okay? So we're going to look at the first one. The limit as x approaches 1 of 4 minus x squared. Okay? So, anyone have an idea of what substitution means? Yeah, we put a number there for the x's. Anyone have any idea what number we're going to put there? Yes, that's all we're doing. So, what we're going to have here is we're going to, so to find this limit, you're going to take number 1 and plug it into this function, 4 minus x squared. So it's going to be 4 minus 1 squared. Well, 1 squared is 1. 4 minus 1 is 3. So the limit as x approaches 1 of f of x, in this case 4 minus x squared, is 3. And you're done. That's how you find the limit. And you could graph this, and you would still come up with the fact that it is 3. All right? So, let's look at this one right here. The limit as theta approaches pi over 2 of sine theta. So, using substitution, what are we going to do? Pi over 2, so it's going to be sine of pi over 2. Now, this is where pre-calc is going to come back to haunt you, because this would be a problem on an AP test that would be something you don't get to have a calculator. You need to know what sine of pi over 2 is. So does anyone remember what sine of pi over 2 is? Pi over 2 will be, pi over 2 is one of the main ones, so pi over 2 is up here. 90 degrees, yeah. So what would be sine, what, so remember the x and y coordinates. 0, 1. So what's sine of pi over 2? 1. Alright? It would be beneficial for you guys to I'm going to get you guys copies of the answer. It would be beneficial for you guys to have that and know some of the big major circles or angles. Alright. Looking down there at the limit as m approaches 2 of m squared plus 5m plus 6 divided by m plus 2. It looks complicated, but what are we going to use here? No calculator. We're going to put a 2 in. This would be something, again, that you cannot use a calculator on the test. So, as Michelle said, we're going to go 2 squared plus 5 times 2 plus 6 divided by 2 plus 2. 2 squared is 4 plus 10, that's 14, plus 6 is 20, over 2 plus 2 is 4. So 20 divided by 4 would be what? 5. So the limit is 5. And again, you could graph this, and you would see that the limit is indeed 5. Do we need to check it? You guys tell me. I wouldn't say yes, but we're short on time. So you can check that in your free time when you guys are back to calculate. Alright? So, I had games on mine. So,
there's my game on here.
Okay. Limit as x approaches 2. Alright? Of 3. So, we have just the equation, just the function 3. So, what are we going to do here? I don't see an x up there. It is just 3. Good job, man. Because, well, because this is x approaches 2, this is x approaches 2. Is there an x here? No, it's just 3. Can't make one. That'd be 3x. That's the entire function. Alright? So the answer is 3. Now, looking at that, why would that be the case? Well, if you think about this, right here, this function, this 3, if you remember, that's a constant function, it's a straight line. So what that means is, you would have drawn the graph of that. That function would just be this, so straight line all the way across. Alright? And obviously, as x approaches 2, which would be right here, you can see that this function is getting close and close to the y value of 3. Everywhere. Does that make sense? Alright. So, this happens though. What happens when you can't use substitution to find the limit? Alright? So, real quick, let's look at this. Negative is lying to us all, and we actually can use substitution here. But why can anyone see why we can't use substitution here? -2. Why? What's wrong with that? Because I just, yes, these all have positive numbers. That doesn't have these. I can do -2 right here for the limit as x approaches 1. I can replace that 1 with -2. What's messed up with this -2 when I plug it in? Okay, so we're going to end up dividing by 0 here. So we'll plug it in. So let's plug -2 in. So we're going to have -2 squared plus 5 times -2 plus 6 divided by -2 plus 3. Alright, so we can definitely see -2 plus 2 is going to be 0. Alright, so we already know that there's a problem. Alright, we also have -2 squared, that's going to be 4, plus 5 times -2, that's going to be -10, so 4 plus -10 is -6. -6 plus 6 is 0 as well. Alright? And we're going to learn about this because there's actually a nice little trick that we're going to use later on down the line. But right now we don't know that. So what happens when we find out that we get 0 divided by 0 like this? We still need to find this algebraic. It still has a limit. Alright? So, any ideas what we can do? No. So I bet you there's a way we can get rid of the denominator. Alright? And what I'm thinking that if I factor this, it might cancel out. There might be a factor in the numerator that cancels out factoring in the denominator. So we're going to rewrite this. Alright? So we're going to say that this is equal to the limit. So we have the limit as x approaches -2. Alright? This top part factors into n plus 2 times n plus 3. Huh? Oh, yeah, it should be n. N. So, do we see anything that would cancel out in the numerator and the denominator? N plus 2 cancels out. Yes. My back box.
Oh, because it adds the box.
No, not 5. You plug 2 in instead of -2. So the n plus 2 cancels out. So I'm left with the limit as n approaches -2 of n plus 3. Alright? And then what would I do now with the -2? I'm going to plug it in, add it to 3, so I have -2 plus 3, which is equal to 1. So the limit of this is 1. Alright? So, what I want to do though is, I want to think about what actually is going on here with this function. Why is it that, what is occurring at -2 that is making this function, we have to rearrange the numerator and cancel stuff out in order to find the limit. Alright, so if we go here and look at the graph, we are going to have So m squared plus 5n. So we have, we're just going to replace that with x. We don't have things here. X squared plus 5x plus what? 6. And divide that by x plus 2. And graph this here. Alright, so what we have here is this is the graph of that function. Okay? So what's happening is this function, alright, at -2, you can't see it, but there's actually a small little hole there at -2. Alright? Our calculator doesn't allow us to see it because the calculator can't just show it. The hole is like, it has no dimension. It's just a little point. Alright? So what we have to know here is that this graph actually looks like the line n plus 3, or in this case on this graph x plus 3. Alright? And so the limit at that point has the same, the limit for this n squared plus 5n plus 6 divided by n plus 2 has the same limit at -2 as n plus 3 does. Because n plus 2 is going to cancel out and be factored. Right? So what you want to know is when you have this type of issue with 0 divided by 0, that's typically going to mean that you have a hole in your graph and that you need to cancel out. You're going to probably more than likely want to factor something, and then just make sure you know that. All right. So here is x cubed plus 8, x squared minus 4. Okay? So, what happens if we substitute in here? So we're going to have -2 cubed plus 8 divided by x squared minus 4. Well, that'd be -2 squared. That's going to give us 8 plus 8, or -8 plus 8, which is 0, over 4 plus, or 4 minus 4, which is 0. Alright, so again, this happens. Alright, we got 0 divided by 0. So, we need to go ahead and factor. Alright, so we have the denominator is really easy to factor. So we have x plus 2, x minus 2. Do we know which of these factors is going to be the one that's going to cancel out here? We're just looking at this. Yeah, why? Not quite. Why would x plus 2 cancel out here? What is, when we plug -2 in, what's happening when we add 2 to that? Which one of these is causing the problem when we plug in -2? And it gives us, when I plug in a -2 to this x plus 2, that's the one that's giving me an issue. Alright? If I put -2 and it's -2 plus 2, now I have a 0 in my denominator. So I know that x plus 2 is going to be one that cancels out. Alright? So, I'm going to do a quick little bit of side math. So, I just need to find out what the factor that is real quick. Alright, so focus. Alright, so this top part is going to factor into x plus 2, and you're going to have x squared minus 2x minus plus 4. Alright? So, again, we notice that the x plus 2 cancels out, and the x plus 2 cancels out. Now we are left with x squared minus 2x plus 4 divided by x minus 2. At this point, what are we going to do? We cancel out the problem, right? Yeah, we cancel out the issue that is giving us a 0 to 0. We're going to plug negative 2 in. So we're going to have negative 2 squared minus 2 times negative 2 plus 4 divided by negative 2 minus 2. So that's going to give us 4. This is going to be minus negative 4, so that's actually 4 plus 4, it's 8. 12 divided by negative 4, so it's going to be equal to negative 3. Hopefully you guys check on that. Because you guys were not checking on that.
Oh, tell me out of this one.
Alright. Questions about that?
What does that do? Will we have to do that over there?
Not sure. Maybe I won't know. We can talk about that. Let me just check. Right? This one?
No,
Yeah, we're fine.
I wasn't talking about that one, I was talking about over there.
Yeah, I know. So, again, so we start off by looking at this problem. The first thing that you should always try, guys, is substituting the problem, like substituting the number in, because the best you can see right off the bat, which and sometimes you will be able to, substituting it in, if you can do that, that's much easier and obviously much more perfect. But let's just check. So we plug in 9 here. So it's going to be 9 minus 9 over 3 minus the square root of 9. 9 minus 9 is 0. 3 minus the square root of 9 is square root of 9 is 3. 3 minus 3 is 0. Alright? Alright, so let's just look at this one. We're going to Alright, guys. So what we're gonna do here is so we're going to take this and we are going to do this. Alright, so we're gonna have 9 minus x.
You want to rewrite this?
Nope. Yeah, you're gonna wanna write this work down there. So you have 3 minus the square root of x. So what we're gonna do is we're going to multiply this by 3 plus square root of x over 3 plus square root of x. Right? So what we have here is we're just going so on the top we have 9 minus x times 3 plus square root of x over, I'm going to distribute in the denominator. 3 times 3 is 9. 3 times the square root of x is plus 3 square root of x.
Wait, which one are you just doing?
And this times this. So then I'm going to have negative square root of x times 3, which is going to be minus 3 square root of x. Then I'm going to have negative square root of x times the square root of x, which is going to be minus x. Alright? So, that point, what I noticed is that the 3 square root of x and the minus 3 square root of x cancel out. Alright? That leaves me with 9 minus x times 3 plus square root of x on the bottom. And then you have 9 minus x on the bottom. 9 minus x's cancel out. You're left with 3 plus the square root of x. When you plug in 9 there, you're going to have 3 plus the square root of 9, which is 3. So you have 3 plus 3, which is 6. Alright. More than what you're going to need to. What is your guys' home? What's the other? What you guys' home?
I don't know. I know I wasn't on.
Okay. You guys are age 56, 7 to 28, 50. So what I want you guys to work on is I want you guys to try to get through. I want you guys to get through 22. Actually, make that 23.
So you want to do 7?
I want you to do 7 to 23.